a couple of things before we started. Everyone received the email I sent yesterday. So yeah, I'll just quickly repeat a couple of things. So I updated the file for homework 1 questions, just in case you purchased the textbook that is another edition, so the problem might be different. So I posted the problems, make sure you write the right one. Also, you might have already received email from Barbara from the help desk regarding to your MySQL account. And for that matter, I think I'll talk about it next week because has any one of you successfully connected to CSE network before on your laptop? Like VPN to CSE. Sounds very unfamiliar, right? The whole process, they just changed, I think, in the summer because we had this cyber attack. So it's kind of complicated, but you will need to learn how to VPN to our CSE network in order to access the MySQL account Barbara set up for you from your laptop. Otherwise, if you want to use those accounts, you will actually have to go to the computer classroom. Okay. Other things. So how is everyone's project? Have you guys started? So 2 weeks left from today. You will have to present it and turn in the document, right? Just want to remind you, don't forget. If you have any question, you can seek for help from me or the TA in our office hour or through email. Okay? Last thing, today before we get into the lecture, we will get on some hands-on experience today. But before we do that, I want to just quickly review the ER model again. Okay, so make sure that you really understand everything, like what symbol means what. So I'll sort of do a summary. If you can, I think the printout of the handouts today, the back is blank. You can draw it on the back of your handouts, the very last page, I think. So yeah, I think our goal is to, you got this suggestion to create sort of like a table so you can look it up when you draw the ER model. Okay. Also, I won't really ask you to memorize all the symbols if when you look up you know how to do it because in the midterms you are allowed to bring cheat sheet so you can organize your own notes in whatever way. Okay. Let's see. So let's review ER model really quick, okay, before we start the SQL programming today. Okay, 3 basic constructs. What is the first one? Entity. How would you represent that? A rectangle. All right. So we say this is the entity. Okay. And the second one, relationship. How would you call this? Call this a okay, diamond. Okay, we said this is the relationship. Can people from the back see my writing? Is it clear? Okay. Third one, third construct. Attribute, okay? So for these 3, I think you guys have no problem. We call them the basic constructs. Or however you call it, as long as you know the 3 basic things are entity, relationship, and attributes. And more formally, we'll actually call this the entity set, right? Entity set, relationship set, so on. Okay. I think the most complicated thing for you guys are the key constraints and the total participation, and the participation constraint. So let's say we have entity A having a relationship with entity B. Okay? If we just put this most simple line, so there's no constraint whatsoever, what to what is this relationship? It's a many to many, right? So to think about it, we put them like so. Okay, say for A, we have only 3 data points. B, only 3 data points as well. So if it's many to many, A, one data point from A can map to more than 1, right? So is B. B can map to more than 1 as well. But is it okay to leave out some of the data points in both sides? It's fine, right? Because we don't put any participation constraint on it. So for this, you can think of it in this way. Oh, no, I'll talk about it later. So this is many to many. Okay, getting a little bit more complicated, if we have an entity A relate to entity B, and we have an arrow pointing from A to B. Okay? Okay, some people already say it's one to many. So how do we get there? We can think of it this way. So also we use the same example if we have 3 data points each. Okay? So when you see this, you read it from the side that has the arrow pointing out. So you can say for each B, there is at most 1 A, correct? So for arrow, it means at most. So after you figure this out, if you map that on here, so for each B, we can only have at most 1 A. In this one, at most 1 A, but maybe from the A side, it can have multiple B's, correct? So if we look at from A to B, that would be 1 to many. Okay? Does that make it easier to figure out why is it 1 to many? For this, we say 1 to many. So then if we flip it another way around, then you know it's many, many to 1, right? I won't put that. The third one, we have A, 1 to B, and also the other way around. What is this relationship? It's a 1 to 1, right? So we can think of it as same thing. For each B, there's at most 1 A. Okay, I won't write it down. And also for each A, there's at most 1 B. So we say it's 1 to 1. If it's a bit harder for you to figure it out, you can, again, draw it like so. Okay, for an A, can only have at most 1 B. Also for B, at most 1 A. Okay, so for 3 relationship examples we talk about here, it is all okay to have data points left out. Okay? So that's because we are not putting what constraint on it? Participation constraint. Okay? So for these 3, we use the arrow. So we call them, we are using the key constraint. Clear? Okay, then we'll quickly talk about participation constraint. I'll start from here. If I'm writing anything really messy, let me know. So consider entity A having a relationship with entity B, and this time with a thick line right here. Okay. So for this situation, we forget about talking with it many to many. Okay, we focus more So when we draw it from here, for each A, there is at least one B, implying when we look at this side, no data point should be left out, right? But whether it's mapping to multiple B or just one B doesn't matter. So, for example, we can have this, or you can even have A having more than one B. This is a bad example. I want to show from the B side you can have data points like that. Okay? This is the first example for participation constraint. Then we think about another one. This time, so I think if I switch side or having both sides, you can figure it out, right? So this time, if we have, here, thick line plus an arrow, then I will say, yeah, for each A, there is what?
Exactly.
Yeah, exactly one D. Okay, so if we look at it from here, okay, this time we change it up. Let's say we have on the B side we have 4 data points, and for 1A relationship to B, just for one data point, one data point, one data point. Because we have thick line, so no data point in the A side can be left out. And because we have arrow, 1A cannot map to more than one. But then it's okay to have from B side data points left. Okay? For these two, of course you can make up more combinations and examples for the participation. Any questions so far? Okay, let me raise here and we will talk about the last two concepts. Oh, 3 actually. So besides the basic construct, remember last time when we were summarizing the error model, we also have a couple of special constructs. Okay? First one being, what can the first one you think of? Weak entities, right? So you can have A having a relationship with B, and how would you make B a weak entity? Put bold line around where? Around B and diamond. So that's also the relationship. So you are denoting this relationship is a relationship between a weak entity and the what? We call this what? Yeah, we call it the identifying only. Okay, so for weak entity, there will be one attribute we use to identify it. How do we denote that? Okay, this is like a name. And there are other attributes. How do we denote the one that we can identify the weak entity? Deducted. Okay, so I didn't say before, but here, for normal entity, it would just be solid line. Okay. Another concept. What is the other additional construct I think of? The is up, right? here's the superclass, right? These up. Normally we put just 2 subclasses, but actually you can put more than one. So I'll just put 3 this time in case you get confused, thinking we can only have 2 subclasses. Okay. So this is the is-a structure, right? So which direction do we read it? Do we read it top down or bottom up? When we read bottom up, right? B is an A, C is an A, D is an A. If you read it another way, then that's wrong. Okay. What is the final special construct? Another one that we rarely use. Okay, I won't draw like a whole example, but just know that you can have. How do we denote aggregation?
Dotted line around the box.
Yeah, the dotted box, right? Okay, I'll just draw a dotted box, but you know what I mean, okay? So that's the aggregation. When do we use aggregation?
You need to specify a relation between relationship set and relationship set.
Okay? When you want to specify this, including the whole relationship in it. Okay? So that will be it for a quick review for all of the concepts we learned for designing ER models. Any questions so far before we get into today's lecture? Okay. If you're done, take out your, wait a second, maybe you can keep your slides on the side first. But you will use a laptop real quick. Nothing is showing, right? Give me 1 second. Thank you. Okay. Awesome. Let's get started. Let's see. Okay, so outline for today, as we just did, we did the ER model design review. Okay. And last time we didn't finish the domain constraints, right? Today I'll wrap it up. I think this is what you got until we finished last time, right? We talk about there's domain constraint, and domain constraint means the values that appear in a column must be drawn from the domain associated with that column. And before we wrap up the lecture, you guys quickly wrote down R is the relation schema, right? What does F mean? That's the field. And, oh, I didn't fix it, but 1 is subscript. So D is the domain, right? So we said DOMI is the set of values in domain I. Okay? So we want to write up an instance of R that satisfies the domain constraints in the schema. So we can write it this way. Okay? So we are saying the instance of R is a set of tuples within fields. So for bracket, we say it's the tuple, okay? We denote it's a tuple. And how about curly braces? When do we normally use it?
Set.
When it's a set, okay? So in this set, all of the tuples following this format will satisfy the rule right here, right? That's how we normally put values that satisfies in a set, okay? To give you an example, let's say today we have this tiny table. Can you guys see from there? Or it's kind of cover. Okay. If I write like around here, can you see it? Sort of.
You can see.
Okay. So this is just like a quick example. For example, the SID of this in the student table. One of the student SID is 5,000, and his name is Dave, and maybe. Just whatever, email, maybe he's 18 years old, GPA 3.2, okay? To denote that in a tuple, following the format of F1, colon D1, so you just say this tuple for Dave is SID, colon 5,000, right? And then name, Dave, and then you keep going listing all of the information, and then finish it with the bracket, okay? You call this a bracket, right? Or no? Kind of. Okay. Then what's this one? Oh, okay, thank you. No, because in Chinese we call this like I think the small parenthesis, medium parenthesis, and large parenthesis. So I had no clue when I saw these things. I have to say them in English. Okay, so that's for the domain constraint. Let's get into SQL language. Okay? So in SQL, instead of calling these tables relations, SQL language, the convention just call it table. So in SQL language, we can actually separate the language itself into two parts. One part that takes care of creating the data, deleting the data, or modifying the data. And everything happens on the table that will change the contents of it. We call it the data definition language. So we say it's DDL. So some of you might already know there's one part of SQL language you do the select from where that I showed pretty early in the lectures. If you do selecting, which is querying the data from the tables, that's not data definition part. Okay, that's not a DDL. So DDL are the parts that actually can change, modify, create, delete, anything on the actual contents. Okay? So really quickly, these will be the things we will use today. If we have time, we might be able to try them all. So for creating a table, you just simply start with create table. Okay? For inserting values, later on we will try it, we will put insert into, and for deleting, we can delete from, and modifying, we will use update. Okay. So now, open your browser and go to SQLfiddle.com. So I was trying it out yesterday, and I kept crashing it, so I'm kind of nervous today. I think the most ideal situation will still be for you to log in to CSE, my SQL account, through the terminal. That would be way more stable. But for lecture purpose, I think this one is pretty nice. But just keep in mind, later on we might kind of ruin it because it cannot handle all of us at the same time. I don't know. We'll see. Okay. So everyone got to the page? Okay. I'm not sure if I type it, it will be super tiny, but we'll try it out. If it's, is that bigger? Yeah. So this is a pretty interesting online tool. On the left-hand side, it's the DDL editor, so that's the data definition part, okay? And later on, we will do some querying from the right part, so it kind of separates both sides. And the querying, almost the only thing we'll do today is just to show the whole table, okay? So we won't do anything fancy like based on what criteria, but we will get into more later. So today we'll focus right here. So you can have your slides on your side. I won't really have you write anything on the slide. So just have it on the side. It's the exact same code we're going to type in. So right now, we haven't done anything on it, right? So if you just click on Build Schema, okay, it will say Schema Ready, right? Then you can go to the browser. The browser will show you all the tables. So if you click on the browser, you'll see nothing there, okay? That's because we haven't done anything, okay? So every time you click into the browser and you want to come back, you just click to DDL editor, and that will bring you back there, okay? Another thing you can try right here, before we create any tables, is to see what's in there, and you can just put show tables. Okay, finish with the semicolon. So for things you type in on the right side, if you want to execute it, this might take super long, but sometimes it's slightly fast, so it just depends on the auth. So you do click Run SQL, and wait a little bit. Might take very long, but yeah, when it finally finished executing, it will show you there's 0 record because we have not yet created anything. It will take very long today, because we are all there, but anyway, let's try, while waiting for it, we can create some tables, okay? So let's say we want to create the student table that we kept talking about. So as I said before, we want to create a table. We start with create table, okay? So you do create table. That's how you're going to start. Is that small, or you can still see it? People from the back, can you guys see it? It's finished, yay. Okay, so record count 0, okay? So you start with create table and say we want to call it the students table. You just put students, that's the name for the table. Okay. After that, we can start specifying our schema. Okay. So the first field is the student ID, we just put SID. Okay. And you press a space. Then we want to specify the domain constraint for that field. So the example we talk about, I think we just specify it as a string, right? So in SQL, we can put character 20. Everyone knows what that will mean? also implying you cannot exceed the limit, okay, when you enter values. Okay, I'll type in the rest of the field in the domain. So say we also want name, and we also want the login. So the age. For age, we just want integer. Okay. Then GPA. So when you're ready, you can click Build Schema. Okay, building schema is a bit faster. Okay, so after you build the schema, you can click to the browser. And ta-da, that gives you the table. Okay, and if you expand table, you can see it shows the schema you just typed in. Okay, and let's go back to video editor. If you are very patient, then you can click Run SQL again, and that will give you the empty table for now. Okay. So that's for creating the table. While waiting for it, I'll tell you another way that you can show the schema from the right-hand side. If you do describe students, okay, then that will return you what are the schema and domain constraints you set for the students table. So if you look at the this create table we just typed in, have you noticed that we are not specifying something that we talk about when we are designing ER model? So we have not yet specified primary key. But when we built the schema, did it say any error? Not, right? So, yeah, that happens. Okay, just, so that might happen to you as well. Okay, that's very sad. Okay, so anyone can think of why SQL allows you to not specify primary key when you create a table?
It's default.
Hmm?
It's by default.
By default, or maybe there are other usage.
It depends on the requirement. Like suppose if you are taking, data, redundancy is okay, then you can go. Without specifying any constraint or key attribute, you can go ahead with creating the table. But if you want to eliminate redundancy, that you want to maintain uniqueness across the table, then you have to go with key. For a single query, if you if you select query fetches more than one record, then you don't need a key. That is your requirement. For uniquely identifying the entity in the entity set, we need a key. So, but by default, SQL allows both. Uniqueness, non-uniqueness.
Yeah, that's a really good answer. And another reason is because the relationships are also stored as tables, right? And for relationships, do we have primary key for them? No? Okay. That's my own answer, I think. So that will be for if, for creating a table. I'm not certain if this happens and you refresh it, maybe that'll be better, but I'll just keep going. So after creating a table, we want to add data into it, okay? So then we want to use insert into to add any values to the table we just created, okay? So we want to insert into the students table, so you insert into and you put the table name, okay? And you want to put the order that you will type in the value. So you just quickly type in same thing here. Okay. To enter the values, we put values, okay? And here you can make it up however you want it. I'll just follow the example. So we have, I think we have Smith in our textbook example. You can put whatever, like your name. Okay, so if you do that, then you can insert a tuple. Okay, like that. Let's try building the schema and see whether it will work. So apparently the schema is built, but if you go to the browser, it will just still show you the schema of the table, right? So if we want to see what are the contents in the table, what you can do is to do select all from, this we will learn a bit later, but for now, it's just querying the table saying I want to select all of the fields from the students table, okay? You guys know that means all, right? Select all from students. Maybe it will work, maybe it won't, but if it works, then that will show you a table with the contents we just added in. So what if we want to add in multiple tuples? Yeah. Hmm?
Just following up whatever this saying that is in like the area is equal to zero.
Yeah, I didn't put so don't forget to put semicolons, okay? I think on the slides you can do them. So if you want to add in multiple tuples, okay. If you want to add in multiple tuples, what you can do is put a comma right after the tuple, the first tuple, and then you can do another one. Okay. Let's call him Joe, and maybe Joe studies music. He's 24 years old. GPA is 2.3. Okay. So if you do that, putting a comma after the tuple and then continue the next one, you can put multiple tuples into the table. I guess I won't mess around from the right hand side now. I'll focus on the left hand side. Okay, so since we are following all of the rules, if we build a schema, it's not going to give me any error, right? And from here, so it's schema ready, successfully. But because right here we actually specify the domain constraint. So if we violate it when inserting the values, let's say we change the 2.3 into ha 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 because we think it's like a joke. Then you build the schema, then it will not be correct. Okay? So just remember, this SQL will make sure you enter all the values following the schema you just defined. All right. So these are for adding values into the table. The next thing we want to try out is modifying the table. Okay? Let's say we already store these two students in here, and we want to update the student's information. So what you can do is to put update students. And on the handout, on the slides, I put students S. Okay? I'll talk about why later. So you want to update students, you put the table's name, and then you give it like a nickname, okay, or another identifier, S. We want to set the age in the table to increment by 1, okay, where the tuple has student ID. So by doing these, it will go to find from the table whose SID is this, and then update the age by incrementing 1. Okay? Can anyone think of why that we put an S right here? What can the uses, like the usage and purposes of it be?
They kind of using it in a efficient way, like as students got AD style, this is kind of eliminating what they want now.
But when we only have one table, it's actually fine if we just say set age equals to age plus 1. Right? If we don't want to specify the nickname is this. So the main usage will be when we have multiple tables. Okay, so say we want to update, and the criteria you're actually comparing from other table, then say we have a students table, if we have a course table, then we can have the students table as S, course table as C. Okay, so that can make things clear. It's just to avoid you. Huh?
Is it for avoiding ambiguity among columns, like suppose two tables are having same column name?
Yeah, exactly. So I was just gonna say, if two tables, they have the same field names, then you can say, oh, this is the age from S, that's the age from, let's say course have age, okay, then that's the age from course. So that's for modifying it. Okay, everyone has that? So I think I won't execute this because they won't show any difference from here. Delete that. So if you want to delete one tuple or some tuples following certain criteria, you can do delete from table's name, where here I will just not use like students as S, okay? Where the tables, where the name is, okay? So if you do that, then it will go to find in the students table whose name is Smith, and then take out the tuple. So if there are multiple students named Smith, by executing this, all of the tuples with the name Smith will be deleted. Okay. Okay, the next thing we want to try out is to, we call it alter the table. So the main usage for this is after you build the schema, maybe you think, I want to add a column in the table. Then what you can do, you can do alter the table, and you specify which table you want to alter. Okay, and you add column. Okay, we call it whatever the first year, and then give it a domain. Okay. So for altering, not only can you do add, you can also do delete. Okay, so we alter the table students, and we add one column, first year, and we specify the domain constraint to be integer. Before we take a look at how the table will be like, what do you think will happen? What will happen for the two tuples that we didn't originally specify the first year values? What should SQL do with it?
It won't alter the existing ones.
Hmm?
The existing ones will remain same, and this new column will be added as, it will be added with empty date.
Yeah, so for those we type in first, but we have not yet specified the first year, by empty data, so SQL will give it null value. Okay, that would just be null. Okay. So then let's try out. 5 minutes left. Let's try out two ways of destroying the table. Okay, the first way is called truncate. So if you truncate students, we store in the table. Okay? So if you go to the browser and take a look, the students table is still there. Okay? But if you really want to delete the whole table, you don't even want the schema to exist there, you use drop. Okay? So after you drop the table, if you build the schema, and then you go to the browser, it's not there anymore. Okay? So there's a difference between truncate and delete, and drop. So drop is deleting both the schema information and the tuples we stored. Okay? So when you go back and try it out, I really want to try it out now. When you go back to try it out, you can try out the, both situations and do the select all from students to see how it looks like. Any questions so far? Let me just quickly talk about the integrity constraint. Okay? So we'll go back to the slides. And I'll keep the rest of the exercise in next time. Hopefully next time I can come up with a better way. Okay, for integrity constraints. Okay. So when we talk about the integrity constraints, that will be the conditions that must be true for any instance of the database. Just like we said before, we will specify the schema, and for whatever tuples you enter into the schema has to follow it, okay? For example, for student ID, you follow the character 20 or 30 that we just specified. So some of the examples for integrity constraints. What will be the one that we just learned that you think will follow that one type of integrity constraint? The domain constraint. Okay? Domain constraint is one type of the integrity constraints. Also, later on when we design using the SQL, you can also specify saying no two students have the same SID. That will also be another type of integrity constraints. So, when will integrity constraints be enforced and specified? So that will be when the schema is defined, just like when we are creating the table. That's when we are specifying the integrity constraints, right? And when will it be enforced? That will be when the relations are modified. So that's like when we are inserting values into the table, that's when the relations are modified. The integrity constraints will also be enforced. So database management system should not allow illegal instances. We have only 1 minute left, so I will just jump right to the reminder. Okay. As you can see, I have a bit more time yesterday, so I did a lot of things even with decoration. So don't forget, homework is due next Friday. Okay, I updated the questions. Also, project due next Friday. No class on Monday. Everyone knows, right? Don't come. I won't be here. And also bring your laptop again on Wednesday. And here's the reading. I realized I haven't given you guys readings for a while. I forgot. And everyone knows it's free donor day today. I'm going, so you guys should go. It's on the Fraser Street in downtown. Actually, right after we finish the class. It's 9 a.m. to 9 p.m. There's a bakery called Good Sea Company or Bakery. Go. Free. Yeah.